Hello friends, welcome back to my Golang programming tutorials. I am Kishore. In this particular video, I am going to talk about arrays, flow controls and functions. Let me jump right into my IntelliJ IDE. Arrays in Go are similar to arrays in other languages in C and Java. Arrays are continuous sequence of homogeneous elements of specified length. Once array is declared, the size is fixed, we cannot grow it. You can use the expression that is specified here in order to declare an array. Of course, you can have the size next to array name itself. Once array is declared, it will be initialized to the default values, that is 0 for ints, empty value for strings. Once the array is declared, then you can start initializing the values separately using the index values. Arrays are 0 based index. You can actually print the array using fmt.println function. Apart from this, you can actually declare and initialize the array values in a single line using : equals syntax. You can use the length function that is available in order to print the length of an array. If you want to iterate over array elements, you can use the range function. Range can be used not only to iterate over array elements but also iterate over other data structures too, which we will see in future videos. If you use range, it will give both index and value. You can assign those values and then print them. Let me execute this particular program and see that it worked as expected. It printed the array, it printed the length, and it printed both index and the value. For some reason, if you don't care for index, then you can just use underscore for it so that it won't complain about not using the index value, and you can remove that. In this case also it works perfectly fine. That's it about arrays, I think. Let me move on to the next, flow controls. The flow control statements in Go are similar to flow control statements in other languages. It has support for if, switch, go to and continue. Even though the behavior is same, there are subtle differences in terms of syntax. Let me move on to the demo of if. I have used runtime.num CPUs in order to get the number of CPUs that are available on my system. If my number of CPUs is greater than 1, I am printing that your system is a multi-CPU system. Otherwise, I am printing that it is a single CPU system. As you can see, I have omitted parentheses here. If you want, you can put it, but the standard practice is to omit them. Another thing to remember is you must have the curly braces. In languages such as Java, you can actually omit them if it is a single line body. But in Go language, you must have curly braces. Another subtle difference is you can actually initialize as well as put the condition in a single line, as I mentioned here. As you can see, it works fine without any issues. Then switch statement. There is a subtle difference in switch syntax. That is, for each case there is no need to return, no need to have break statement. But apart from that, it is similar to switch statement in other languages. You will have switch followed by the value. It can be both integers, strings, and you will have multiple cases, and you must have the default case too. Go, even though it is modern programming language, it is still supporting Go2, maybe because of the situation that I have mentioned here. In this particular program, all I am doing is I am assigning the variable I to some random integer which is less than 10. Similarly, j to some random integer which is less than 10. As soon as I hit a scenario where I is actually greater than j, then I am using the go to statement to jump to the block which is cleanup. So as soon as it hits this go to, it will jump right into this block of code and it executes whatever is there within that block. Remember that since it is jumping directly to this block of code, nothing in between will be printed. If at all you want to have block of statements in Go, you can use this kind of syntax and have blocks of code. That is about go to. And continue statement is similar to any other language. In this particular program, I am printing the even numbers. I am iterating from 1 to 10, and as soon as I find that the value is not a even number, in that case I am using continue. If you use continue, the rest of the body within that loop is not going to be executed. In this case, the printf will not get executed, but it will continue with the next iteration within the for loop. So these are some of the conditional statements that are available. There are subtle differences with respect to other programming languages. Now let me move on to loops. There is a single keyword for looping in Go, that is for. The syntax is similar. You can initialize the variable and have a condition for the loop termination and the increment statement, and within the body you do whatever you want. Let us say Go is not providing while looping, but you can use for itself in order to get the functionality of while. Initialize the variables upfront, and for have just conditional statement within which you can actually do the increment. So these are the loop constructs that are available in Go. That's it about flow controls. Let me move on to functions, which has some kind of differences with respect to other programming languages such as C and Java. Functions are central to Go. Go supports first class functions, higher order functions, user defined functions, function literals, closures, etc. I will be discussing all of those in my future videos. This rich support actually provides us a way to do functional programming in a strongly typed language. You can declare and define a function using the func keyword. After the func keyword, you must have the function name followed by the list of arguments that it takes. After that, you must have the return type. If your function is not returning anything, then you can omit this like this. Observe that this is a bit different from other programming languages like C and Java, where the return type will come before the function name itself. After within that function definition, you can have whatever the logic that you have for that function, and then must have the explicit return statement if at all it is returning something. Note that the explicit return is required. It won't be automatically returning the value of the last expression as it happens in some of the other languages. You can actually define a function in another way with respect to the return value as demonstrated in the function add different. As you can see, for the return type, I am specifying it as an int. Apart from that, I am also specifying the variable. What this means is that my function is going to return an integer type, but the variable is sum itself. So within the function body, all I am doing is I am adding the variables a and b and assigning it to the variable sum. So after that, if I simply do return, it will return whatever is the variable that I have actually defined within the function definition. So in this case, we are actually declaring an integer named sum and assigning that value within the function body. I think this is a bit different from other languages, but basically in the method function declaration itself, you are specifying the variable name so that it gets initialized to default value. Then you can assign it to the required value as you need. Another interesting thing is Go supports return of multiple statements, return of multiple values, which is not the case in other languages. In Java, you need to actually create an object and hold multiple values and return that object. So in this particular case, it is taking two integers and returning two integers, and those integers are of variables sum and product, which are initialized in the function declaration itself. I am assigning the values a plus b to sum and a into b to product, and just using the return statement without any explicit return of sum and product. It automatically knows that the two integers must be returned of variable sum and product, and it will return both sum and products. You might be wondering how you actually use the returned values. That you can see in the main program. In the add multiply, I know that it returns two values, so I am assigning both sum and product and printing them. This we have seen just now while we are iterating over the loop using range keyword, where it was returning both index and value. Everything in Go is pass by value. That is, the function always gets a copy of the thing that is being passed in. For instance, if you pass in an integer value to the function, then it makes a copy of an integer. Similarly, if you pass in the pointer value, then it makes a copy of the pointer, but not the data that it points to. That we can demonstrate using pass by value and pass by reference. In pass by value, if you see, it takes an integer and changing that value. Whatever value that we have assigned within this function will not be reflected in the main function. If you see here, we are actually calling by passing in the 10. Even after calling the pass by value, the value will still be 10. In case of pass by reference, instead of taking an integer, we are taking the address of the integer. In this case, we are using ampersand keyword and passing in the address of the value. Since it is always passed by value, it will make a copy of the address, not the integer value, and it will dereference it and actually change the value at the address that it has a copy. So it goes to that address and actually changes the value to 100. So after executing pass by reference, it should print the value 100. These are standard things. Go also supports recursion. So this is a standard Fibonacci recursive function where it actually prints the Fibonacci values. Let me there is nothing in the main that I need to explain. I have explained how to actually take multiple values, pass by value and pass by reference, and actually the invocation of functions, which is pretty straightforward. Let me execute this particular program and see that it actually does what it is supposed to do. It is adding 110 to 110 differently. It is same, sum and products are printing correctly. As you can see, pass by value is not modifying the value 10, but pass by reference is modifying it to 100, and it is printing the Fibonacci value without any issues. Even though there are some interesting stuff with respect to functions and flow control statements, there is nothing great in this particular video. I have done this video just to make sure that both of us are in the same pace. That's it for this tutorial, guys. I will meet you in the next tutorial, where I will talk about higher order functions, closures, first class functions, and many more in Go language. Thank you for watching. Have a great time. See you.